Hello, this is the oscilloscope mode on the disting EX. This is a dual mode algorithm, so it takes up just half of the EX. So for this demo, I'm going to be using the other half as an LFO to generate some waveforms to visualize, and another disting Mark IV here to generate another waveform. So the oscilloscope, it's a simple two-channel oscilloscope designed for simple visualizations of waveforms in your modular rather than any particularly detailed measurement, for example. Two inputs X and Y. There's one coming from this LFO. Turn it down, speed it up. And here's another one into Y. Various display modes you've got. It's the first parameter, display. Option 0, overlay. The two waveforms are just drawn in the same space. Stacked. Each waveform gets half of the display, like so. You've got the option to just draw the X waveform or the Y waveform, fairly straightforward. And then you've got XY mode, which I'll come back to in a moment. So let's go back to this overlaid for now, I think. Other parameters, min V, the minimum voltage that you want to be able to see, so it goes from -10 down to, it goes all the way up, so you can focus your range of interest on whatever you want to measure. These waveforms are plus or minus 5 volts, so that's the setting I've got here. Next parameter, max V, is the maximum voltage, so you can change that to what you need. Parameter 3 is the time, so that's the time represented by the full horizontal width of that little window there. It's on 200 milliseconds at the moment. If I change it, obviously it goes slower. So depending on what you want to measure, if you want to measure some very slow moving LFOs, you might want to put it all the way up to 10 seconds. Or if you want to look at some details of some high frequency audio, say 2 milliseconds is or 1 millisecond even. Value 0 for this parameter is auto, and then it tells you the value it's using. Now that's using the time between triggers as the width, so let's actually move on to the triggers. Parameter 4, trigger mode. By default it's free running, which just means it continually runs and updates the display. And then you can trigger on rising or falling edges of the two waveforms. So for this, I'm going to put the display mode back to stacked, so you can see them both more easily. Okay, so at the moment, the trigger mode is X rising. So basically, whenever the X waveform goes through the threshold, which is set instantly by the Z knob, then it's going to run one sweep of the time scale and display the result. And because it's locked onto the X waveform, that waveform will appear stationary. If I draw X falling, then it's going to be the falling edge of that. Similarly, Y rising, now it's locked onto the Y waveform, and Y falling. So that displays the time that I meant, the automatic time scale that I mentioned as well. Because it's locked to Y, it's using the time between triggers, so you see the whole sweep of the Y waveform, whatever the frequency of that waveform actually is. If I change it back to not auto, say fixed time, then it'll be triggered, but you don't necessarily get the whole waveform. It's just going to be run for the amount of time that you've asked it for. Like so. The other parameter we've not mentioned is parameter 5, is the draw mode. So it's either lines or points, and doesn't actually apply to stacked mode. So I'm going to turn that back to, let's do only X. Okay, so draw mode. And so let's change the trigger mode so it's triggering on X. Okay, so there's our waveform. it's drawing points. So that looks okay when it's nice and slow, but when it's fast, you can start to see gaps in between the dots, especially also if I change this to a square wave, you can see the gaps in the square. Whereas if I change the draw mode to lines, then it joins them up, basically. Put that back to sine. So there you go. So lines, points. Depending on what you're looking at, either mode could be useful. And then the only thing we didn't do is the XY mode. So rather than showing time on the horizontal axis and the two waveforms on the vertical axis, this uses X and Y as the X and Y directions of the signal. So with some sine waves in, you end up with these rather nice Lissajous patterns. And you can see whether things are in phase or their relative frequency. And then dots versus lines is very apparent in this mode as well. Let's put it back to lines and change the time. Let's put it to auto. There we go. Actually, no, let's not have it on auto. Let's have it on something nice and fast or slow. Free running 100 milliseconds. Let's see how that looks with these waveforms. Well, then you can see it sweeping around because we've got really slow waveforms. But let's speed those up. There we go. Endless fun. So that's the oscilloscope anyway. It's a handy little tool to debug and visualize what's going on with your CVs.